All right. Is that unique to squares?
So does that mean that this big path that we made is related to pi in some way too?
No, because you didn't go around in the circle.
Oh, it has to be start. Okay, you have to come back.
Well, hang on. What about that's a quadrilateral? What about a five-sided polygon?
Or what if it's not a regular? Well, if it's a rectangle, it wouldn't matter, would it?
If it works for a circle, it works for a square, it's got to work for
Yeah, that's
2 data points done. Actually, what about a five-sided polygon? Would it?
So you have a fifth in the center?
probably.
Try it. Do you have paper? Do you have white? You have whiteboard. I don't have whiteboard around this.
Should be a closed curve. For example, okay, if it's straight line, it's infinity minus infinity, but if it's a closed curve.
Nobody else.
Pentagon. I heard pentagon. Someone do a
Let's
hexagon.
do a triangle.
Do a triangle.
So then all of these angles, I think this is going to be there's going to be a bunch of 180s, 5 and
You do bigger triangles? Or maybe you're fine.
that minus that 360, no matter what those angles are.
Okay, so now, what we're doing.
And it didn't have to be regular. Does that make sense? All right.
So I'm drawing the long shape. One unit. Now when I get to here,
So that's a perfect circle. So you need those wedges.
and then do I kind of do this
So the area's
kind
pi.
of smooth thing, okay?
Are you sure those three was that?
Okay, so this
Did I have it right? They got to add to 180, 180 minus c. So if I added up all of those, I'd end up with 5 180s. And a plus b plus c plus subtraction of this, right? And that I already know is 540. And this was 900, so there's 360. No matter what A, B, C, D, and E are, right?
So just to recap, because getting to the brain hoodie stage as the evening wears on. So you're saying if you ride your bicycle down any old pentagon, we'll definitely get circular wedges.
Uh-huh.
And he's claiming these wedges fit together so they all make add up to 360 degrees. And they will piece together the perfect pi because he's doing fact some geometry that he knows the interior angles of pentagon must add up to. These angles is 180 minus those, and voila, all the arithmetic works out beautifully for pentagons.
You could also think of it.
we're pretty happy it's true for an n-gon as well for general n.
And it seems pretty comfortable. We can probably generalize this for any old polygon now, because someone did it for triangles, we did it for squares, and we did it for pentagon. I'm feeling pretty confident. So then, what about a weird curved shape that's not polygonal like this?
Yes.
Well, I heard my colleague here say the word limiting argument, and in some bizarre sense, every closed curve like this could be thought of as a polygon with arbitrarily many sides, but as an approximation.
All right, I'll do a bad approximation. I'm going to pretend it's this polygon. I need another color. I'm running out of colors.
It's going to be
All right. Here is a bad approximation.
Using like fixed theorem?
How's that? It's pretty, is that a? I just try to do straight line
Well, you've
segments.
got a concave angle there.
That kind of. Yeah, I'm trying to ignore it at the moment. It kind of approximates it. So if the bicycle went along the green curve, I'd get these wedges like this. That's what I'm hearing. Whoops, yeah, whoops, I know. We've got a question there, I know. But I didn't draw it right. But you believe this results that polygons have nice angles that always add to 360? In which case, this approximation between the tracks, area between the curves, is pi.
Yeah.
How do you get a better approximation?
More points.
More line segments?
more line segments.
Will they also have area pi?
Absolutely.
How do you get an even better approximation?
Absolutely.
Pi? If every good approximation is pi, what must the true answer be in the end?
Tau.
Tau. All right.